Welcome back to another episode of Oxygen Not Included. We took another 50 cycles in between this episode and the last one to get some cleanup done. I got rid of all this old power stuff down here. I still need to clean up some of the wires and everything, but I moved all of the power up here. At some point, we're going to have to add in some cooling up here. We also finished the oil biome. We now have everything fixed down here. I redid this design a little bit. This is based off of Francis John's design. It's not my original design, but I kind of just did it from memory, so it took me a minute to try to figure out how to do everything. So now the crude oil fills up pretty full, keeps the oil well covered, so we don't get any heat issues. And then the excess just spills out into the reservoir down here. So this one's running the same way. It's been running for a little while, no problems. This one we had cleaned out all of the area around it and built this one up too. So now they're all running and using up some water to turn water into oil. We also have finished out the bottom here. I had to make some changes and move some stuff around because I had to raise this floor up one more level, so I had some more space for the oil well here. So I have a double layer of insulation here because I wanted to have that pipe going through insulated tile. It's probably overkill, but I just wanted to make sure it was good. Oh, that's my oil drain pipe. Yeah, that's right. Okay, so then few other little things I still need to clean up down here, but mostly this is done, and we have this all leveled off, so all this oil will flow, work its way flowing down all the way down here to the end where I have a pump, and this pump will pick up from this bottom tile here, so it will drain all the oil out. And then I have some pitcher pumps to make it so that we can grab oil when we need to for liquid locks and stuff like that. And then I have a bottle emptiers to drop off oil if we have excess oil on the mat. We also have gone through and, for the most part, cleared out the whole map. We still have a little bits and bobs here or there that we need to clean up. Another geyser we found over here. So just little things to do, but that's all gonna wait for another day because it's finally time to get sunk into building this petroleum boiler. So the magma has built up so that we have plenty of it. We're gonna have to do some tricky work in here to push this magma back because I think this is too full for what we need. We will see. We also have this still running, the aluminum volcano that we set up. We'll probably revisit this and do some more work on it, but we have aluminum in here. We're trying to cool it down a little bit, so all I did was put in a radiant pipe in this spot here where it passes through this oil, so we're cooling the oil down. So when I first came down, this oil was 300, and I realized we needed to do something about that because the aluminum in there was actually heating it up to the point where I was worried it was going to flash to petroleum and then eventually sour gas. So this was 340 degrees, I think, and now it's down to 171. So as we cool this down, eventually it'll cool the aluminum down too. But we're going to come up with a better design for that so the aluminum comes out cold instead of dropping off in there to cool. But that's for another day. So we have 23 tons of aluminum, which is more than we need to do our counterflow heat exchanger here. And we have all the magma we need set up. This thing will pump out plenty of magma to keep us going forever. So we're going to start building this. It's probably going to be, I'm going to be jumping back and forth showing clips as I do it. And, I'm not going to explain it too much in detail because, like I said, this isn't really my design. I'm using Francis John's design, and then I'm going to tweak it a little bit. I'll put a link to his tutorial in my description. so that you can see it if you want to. So, okay, I'll be back once I get the first stages all put in place, and then we'll show you what we're going to be doing. Okay, so first thing we did is severely underestimated how hot that magma is going to be, and nearly killed one of our duplicants. Happens to be Ender. He's recovering, but he came about 30 seconds away from death because I was thinking, I don't know what I was thinking, but I was thinking I want to push this magma back, so I was putting blocks down here, but then he ran all the way down here, was in here doing stuff, and then got knocked out, and I didn't have any triage cots set up, so I quick set a couple up and kind of pulled out of there just in the nick of time. So that wasn't very smart, but it's okay. We're going to have to approach this a little bit different. The issue is what we want is we want magma to flow down here, but we don't want it to go full force like it is. So we need to build some blocks here to push it back out. And in the end, we want to have one block here and then an air gap on top. So what we're going to do is come up here from above so we can try to place blocks down diagonally and work our way out without duplicates having to go into the magma. See how it works. But I'm going to work on that while Ender recovers from his near fatal injuries. The other problem is that Ender is our doctor, so I had to promote a second doctor so that somebody can come along and treat him. But eventually I got to set up a hospital and everything else. But okay, we'll be back. Okay, we worked our way in here to get far enough in so that we can push this magma back. Calico is able to place this block in without actually getting in the magma too much, so she will be alright. So that's good. So now what we got to do is work our way back out the other direction. So hopefully, I think that we can do deconstruction through the diagonal too. Yeah, we can. So now we're going to have people work that way back out, and that magma will go the correct amount. So this, we want this to be 8 blocks from here to here. So that's exactly where we want to go. So we'll pull these blocks out, we'll place more blocks in place, and we'll work our way backwards, rebuilding as we go. And then what should happen is, actually, I think we ended up over pressurizing this magma, so it may not do exactly what I want. We'll find out. What I want to do is set this door back to be no one's allowed in there. I don't want anybody in there with the magma. So this is still reachable. Ender's coming to build it. It means you healed already, buddy? Good job. Good job on healing quick. Okay, so place 2 more blocks like that. Place those. Oh, no, I don't want to place this one. I think this might be a little tricky. Place this one back so that I can get rid of this tile. Okay, we'll be back once I get the whole thing set up. we got in the first steps of the build in place. We're going to set up, next thing we set up is the automation to connect all the doors so they control in the right place, and then start putting in some of the wiring and everything. So this section here is all designed to control how much magma flows out of the build at a time. So it drops in just enough into this area that it stores it, and then when we need more, it'll drop it down. It's going to get stored here against the door that will transfer the heat directly up into an area where oil is dropped in and boiled into petroleum, and then the petroleum will flow back down out of the build after we have the counterflow heat exchanger in, which is a bit of a complicated thing, but I will explain it how it works once it's in place, because it'll be easier to explain it. So be back once I have all the automation in place. Gotten all our automation wires in place. Temporarily, they're all just turned on to keep doors open because I'm vacuuming out vacuuming out all the gases from in here. Then we're going to build everything back up, and this section will be finished. We'll have to pull the ladders out and stuff like that and open this up to the magma. But basically the idea of this automation is that this sensor, when the heat in here goes below 430 degrees, will run a quick clock that will close this door. We'll open this one so magma falls down, and then as soon as the magma falls down, it will close this door, and then that heat will start transferring through these tiles up through this temperature shift plate into the door, and then up to where we have the actual boiler set up, and then it automatically sets itself back off, so it resets the position for the next time, opening this door, letting magma collect here, so that the system is set for the next time it does it. And so basically it resets itself every time this gets too cold so that it can't do the heat that it needs. And then this automation will open this door when this starts to get too hot so that we don't overboil our petroleum. So it's a very delicate little system. Again, this was designed originally by Francis John. It's pretty crazy the way he came up with this stuff, but I just want to have this as a starting point so I can get it working, so I can learn how it works a little better, and then I can come up with some changes to it myself that I'd like to do in the future. So we'll get it, this going to take another couple minutes just to vacuum this all out. We'll get it sealed back up, and then we'll start working on the heat exchanger on this side. Most of the build in place, doing a couple little last minute things to get everything set up, but I'm going to go through and try to explain how this is going to work while the last bit of the air gets vacuumed out. So you don't necessarily need to vacuum out the inside of this boiler, but I'm going to. All you need to do is make sure there's only one gas in here, because if there's two different types of gases, it can cause blockages. But I also, my setup is much more open, so it shouldn't be an issue anywhere. But I'm just gonna do it to be superly cautious. So I did a few things that are a little different than you would normally see in this setup, and one is that I left the passages here too wide, and I left some ladders in place. That way my duplicates can get all the way around inside here. This will be closed back up once this is vacuumed back out again, but so they won't be able to get into this side. But over here, a duplicate can get in to anywhere we need, so that if we want to make some little minor changes as we tweak it, we can, because I'm not quite sure how long this heat exchanger needs to be based on the aluminum, because I've never used the aluminum before. But the reason we're going to go with aluminum is because aluminum has a really high thermal conductivity, as opposed to, let's see if I have gold that I can just click on to look at it. I think maybe I used some gold in this system. Yeah. So if we look at the gold here, its thermal conductivity is 120. Aluminum's 410. So that should mean that we need a much smaller section of pipe to exchange the heat that we need to. But basically the idea of this is that we have oil coming in through this radiant liquid pipe, the crude oil, and it comes up and works its way up to the top, and it drops out here into this section, which is superheated so that the crude oil will flash into petroleum and boil. And then as the crude oil drips down and becomes petroleum, it'll work its way up and it'll flow down these tiles. And so it's called a heat exchanger because it will exchange heat between the liquid inside the pipe and the liquid flowing back down to get piped out. And so crude oil comes in colder than we need it to be, and it picks up heat from the petroleum, and that way when it gets to the top, it's already almost petroleum and will flash to petroleum as soon as it hits the tile down here, and that way it can keep boiling faster. And the petroleum, as it comes out, will give its heat off to the crude oil, so it'll cool down as it drips its way down to here, meaning it'll be cooler before we take it out. So it works both ways, and it's very beneficial to us. There's a lot of little tiny bits and bobs in here that I may have gotten wrong, so when we go to fire it up, I'll be doing a save so that we can go back to change anything if it is disastrous. But if it's little tiny tweaks, we have the ability to get in here and change things. So as soon as we get all these gases pumped out and this sealed back up, we can disconnect the automation that's holding all these doors open so that I have them locked open so that we can get all these gases out from the whole system. We'll cut off those wires so that it's all set up in its position, and we will fire it up. So it's going to take probably a few cycles to get all that done. So we'll come back once we're ready to fire the thing up. We've got this still pumping. It's taking a little longer than I would have thought of. So we knocked a few blocks out to kind of open up some of these passageways to get air flowing a little bit more. But we're down into the low grams, so shouldn't be too much longer. But one thing I did set up is I realized I hadn't run the pipe up for the crude oil. So crude oil now goes all the way from the bottom corner of the map, gets pumped up, and I emptied out all the pipes that we had going to the old setup here. And this pipe goes all the way up to the top, and then across, and then back down to right here, ready to be connected to pump in. And then as far as the output, I just set up 5 liquid reservoirs, which will hold a total of 25 tons of petroleum once we start it flowing. Eventually we will connect this up to petroleum generators and to our plastic production, that kind of stuff, and probably make a reservoir. But for now, I just want to have somewhere for it to go so we can let this run for a while so we can make sure everything is working correctly. So be back in a few more minutes once all these gases have been sorted out. And yeah, shouldn't be too much longer. Alrighty, made a save after forgetting to and having to fix a couple things when I fired it up with no liquid in it. But so we have crude oil flowing in, and we have everything turned on. So while it's getting primed up, it's going to take a little while to work because the crude oil is coming in at 34 degrees because I don't have anything to exchange heat with yet. But once this petroleum boiler fills up, and we have petroleum spilling down into the rest of the system, the hot petroleum should flow down and increase the temperature of the crude oil as it comes in so that it won't take so long to flash to petroleum. The concern I have, petroleum, let's look this up quick because I'm not sure what's going to happen here. So petroleum liquid at 540 degrees can flash to sour gas. And this petroleum is it's still quite a bit below that, 400 degrees. Okay, good. So the way this works is that once this hits 403 degrees inside here, meaning enough heat has transferred from this door into the system, it opens the door, which means that the heat coming from here, you can see the heat in this rock is 800 degrees. It's transferring into here. It's transferring through this shift plate into this door. When the door is closed, it lets heat transfer into the metal tiles. So that's increasing the temperature in here. This sensor is detecting what the temperature is. If the temperature goes above 403, which it will slowly rise with that door closed, you can see it increasing in the actual sensor itself, but the cold crude oil is keeping it from going too quickly. As it is increasing in temperature, once it hits 403, it's going to open this door, meaning no more heat can come out. While it's closed, it's pulling heat out of here. So there's underneath this rock here, there's another temperature sensor that says if the temperature falls below 430 degrees, meaning there's no more heat to pull out of this rock that's going to transfer over, it will start the automation on this side, which will fire off and bring down fresh magma. So we'll watch to see this happen once this temperature drops. So currently there's plenty of heat in there to do what it needs to do. Be careful to make sure that this is still increasing enough heat to get this crude oil to switch. It's a delicate little balance here. We don't want the crude oil to overfill and spill out. We want the petroleum to. And petroleum should go to the top. But this petroleum's 350 degrees, so once it hits this pipe, it'll start heating that crude oil, but we got to get a little more in there before it'll start doing that. $359. So if we look at crude oil, its temperature is 399.9. When it hits 399.9, it switches to petroleum. Okay, there we go. Now we have the petroleum flowing down. So let's take a look at. We want to watch the temperature of the contents of this radiant pipe. Looks like it's working okay. So now the crude oil is coming out quite a bit hotter than it was. It was only at 34 degrees. And if we look, the temperature of the petroleum is dropping. By the time it gets down here, it's already down to 43 degrees. So all of its heat has transferred into that crude oil. So it looks like it's working. We just need to see what happens when this number changes over. So we're getting very close to that happening. Oh, that is a problem. We have crude oil made it to its way to the top, so it's not boiling fast enough. Why is it doing that? Well, we'll have to just wait and see. We may need to get in there and fix that. Let's... Hopefully when this switches... Okay, so what it does is it sends a signal which fires up the RoboMiner to break the rock that's there. 25 seconds later, this filter sends through the signal to this door, switching this one to close. So the magma drops down, and now we have heat transferring through this door again because we have 1500 degrees of heat here. So let's watch this temperature rise up really quickly. I think we're going to have some trouble with that crude oil, but we'll see. We just need to get this crude oil up to temp. It's getting very, very close. So there we go. It's flashing the petroleum now. So if we can get this crude oil out of there. Okay, cool. So let's cancel that mop. And let's do a priority 9 on this one here so we can get that crude oil out of there. So what happened here is that this temperature shot above 403, so it opened this door, meaning no more heat could come in. So once this drops below, it'll switch this on, pulling more heat in, meaning that as soon as this cools down enough that it's not turning into petroleum, it will bring in more heat from here. And you can see that this igneous rock's not cooling down very quickly because it's has nowhere for that heat to go. But as soon as the door closes, it's losing temperature quickly. So should stay nicely in balance. Oh, he got all that crude oil out, or Mama G did, she did. Okay, so that's good. Everything there is working good. Let's get these gas pumps out of here. Probably should have done that beforehand, but I wasn't. I just wanted to make sure I didn't have any more problems with it. That's awesome. So that did work the way we intended it. Down here, the petroleum is going to wait until it gets to this sensor, and as soon as there's more than 500 kilograms, then it'll start pumping it out. But we're going to let it fill this little tank up first. That way, this pump stays in liquid all the time, and it's not pumping out small amounts, but also that way it can use the cold petroleum to keep itself from overheating. So this will run forever now, until it runs out of magma, but this should use less magma than the output of this volcano, so we should be alright. I have this set so nobody can come in, so assuming that this works, and we don't have to go in there for maintenance, it should be alright. We'll probably put in an entranceway at the top to make it so we can get in there if we need to later, but we'll cross that bridge when we get to it. One thing that was interesting is that since I fired it up without the oil in it by accident, we ended up getting molten gold that I had to bottle out, and you can see it turned it into a tile of gold right here, which is really interesting. I've never seen it do that before, so I loved it. So what happened is these two tiles melted and turned into liquid gold, so I mopped them up, and they carried that bottled liquid gold down here to this pump I set up, and dumped it out and hit the water, and it turned into solid gold. Interesting mechanic. So we're going to let this run for a little bit. I'm going to let it play and see if we run into any problems. But that was several episodes of work into this one little design. So I'm pretty happy that things seems to be working. Let's see, this sensor here is about to trip, so then we'll start pumping petroleum out into those reservoirs. Good deal. So now we're taking, let's see, we're taking 50-degree crude oil, and on the output we're getting 55-degree petroleum. So very little heat is being lost in the system. It's all being converted using this heat exchanger. So that's quite cool. These we can empty and let that petroleum just add to the mix. Where's that petroleum going? Probably down here. I hope there's space to store it. Yeah, there's a little bit. We'll have to reroute our petroleum so it goes down to our plastic presses. But that's something for another episode. So this is going to fill up really quickly. So the next project that we need to work on is using up the petroleum so that it doesn't overflow. So we'll make a petroleum tank, and then we'll set up some petroleum generators. The nice thing about petroleum generators is they'll generate a lot of power. They will also generate carbon dioxide, which I can use when I set up the slickster farm, because slicksters will take the carbon dioxide and then convert it into oil, which will feed us more petroleum for our petroleum generators. Petroleum generators will also provide polluted water, which we can convert into water. So this boiler, once it's all connected to everything else, will take water, turn it into oil. The oil will turn into petroleum, which will power our base, provide food, and provide enough water to continue the loop and get us more oil. So we basically have infinite food, infinite water forever from this one boiler. So that's pretty awesome. And so we can start using the power from this system to do our next steps of getting into space and doing even more fancy stuff. So I hope you enjoyed watching it, and hope to see you in the next one. Bye-bye.